Hello, folks. Greetings and welcome back to the class. Today, hopefully, it's going to be a little dry. I will give a warning in the beginning itself, right? Because I'm trying to do something really challenging. Is basically, I'm going to explain to you a new product sales demand manufacturing model, right? Then I'm going to show you how I am preparing the data for these. Um, Basically, I'm just showing you some ideas on how you can prepare data that looks realistic, but you don't have to rely on some public data, but you are making up data, right? And I'm going to show you some techniques on how you make up the data and also some ideas on how you can make it realistic, okay? So I'm going to show you that. And then if I have time, I'll show you how you import the data into Power BI, and then how you define relationship, okay, and what's the limitation of it. So to start with, I just created a very realistic model, but a little bit more simplistic of a realistic model, okay. So I have a product that has product ID and product name. Then I have a product cost table. It's a one to many table, right? And the product cost table as a composite primary key, because that's how it is in the real world, okay? The composite primary key as the product ID, which is primary key as well as foreign key, and then the product cost quantity as another primary key. I'll tell you what is a product cost quantity. Basically, when you're manufacturing, depending on the type of product you manufacture, uh, for manufacturing certain volume of a product, it's going to cost you so much. Now, depending on the product, if you're manufacturing another, so let's say that you're manufacturing 50,000 products, okay, it's going to cost you, the unit cost is going to be something, okay. But let's say that you want to manufacture 400,000 of the same product. Depending on the business, depending on the product, it can either cost you less or cost you more, okay. So therefore, your costing is not going to be directly, okay, what's my product manufacturing cost? That's not how it works. The way it works is at different levels of quantity that you're producing is going to cost you more or less, okay. That's why product cost quantity is also a primary key. Then once that is the primary key, then what is that you have in the product cost table? One is the fixed cost. That is, in order for me to run 50,000 items, produce 50,000 items, what's my fixed cost? Fixed cost means whether you actually manufacture the stuff or not, you're going to incur some cost, okay. You're going to have some management, employees, things like that. You're going to have a building and electricity and water and utilities. All that is going to cost you irrespective of whether you're manufacturing or not manufacturing. And that is called the fixed cost of your product, okay. Then you have a unit cost, which is basically to produce the product, you need some raw materials and some sort of labor, okay, and probably hourly labor, okay. So there's going to be a unit cost for that, okay. So what is the unit cost, right? So generally what happens is that when somebody is going to tell you what is the cost, the production cost of a product, they will take the fixed cost, divide that into the number of units, and then find out the fixed component of that cost, and then they will have the unit cost, which is the variable cost, right? And they will add that together and say that, hey, this is how much it's going to cost you to produce a product, okay. That's what is there. Now there's also outsourcing unit cost that's mentioned here, because most manufacturing companies will have some in-house manufacturing capacity, but your sales and demand kind of fluctuates, and therefore how do you make up for it? It's like you might outsource manufacturing the same product. Okay. And in this model, depending on the model, right? Sometimes outsourcing cost is less, sometimes outsourcing cost is more. Okay. But anyway, these costs are important because I'll tell you in the end that when you're building some kind of business intelligence dashboard or report, the executive management will have to look at it and say that, hey, is my manufacturing cost and the outsourcing cost, the mix of manufacturing and outsourcing, is that really providing me some strategic advantage? Am I making more revenue? Am I making more profit? These are things executive management need to look at. That's why we have the product cost table. Okay. Then even though the product cost is telling us something, that there is also a manufacturing capacity. Okay. So I put some date component in here because sometimes manufacturing is seasonal. So that's why I put the month as one of the primary keys. Product ID is again primary key and foreign key. And here you're just kind of having an idea of, so given a product in a month, what is my in-house manufacturing capacity? Okay. Again, this is important because executives may decide to invest on more manufacturing capacity, or they may do things in a way to cut down manufacturing capacity depending on how the business runs at that point in time. So that data is there. Then let's come to product demand. Product demand has four primary composite keys, or composite primary key with four components. Okay. One is the product ID, which is also a foreign key. Then region code. So basically, your demand, product demand, is based on some region, right? In some region that people may love your product. In some region they may not that much like your product. Okay. So for example, that if you're selling snow tires, or tires specialized for cold weather, obviously some of the southern US states may not be interested in that, right? So those are kind of things that, so therefore there is a region code. Your demand is seasonal, so you have a month in there. And then there's another thing is that, hey, how much profit are you making? How much markup are you making for that product? Because if there is increased in product price, there will be a decrease in demand. That is economics 101, right? So you're also saying that, hey, what's my demand based on the price? And then what's the demanded quantity? Okay. Now, generally, marketing departments really, they have a huge science on figuring out what's the demand. Okay. And so we're just saying that there's going to be a table. There is already a table that has the demand calculated for you. Then there is product sales. This is a no-brainer. You have a product ID, region code, month, and again cost markup, because when you're selling these products, again, depending on your business model, generally you sell the same product at different price points at different venues. You may sell the product at a lower price point in a wholesale setup like Costco, and you may sell it at a higher price in a more premium place like a mall, right, or a premium mall. So there are various ways in which you will sell it. So therefore we need to know, okay, at what price you sold how much. That's why you have a markup, and we don't care about the sale price. Here we only care about how much you made the markup and sold the product. Okay, so this is actual sales. So, and the reason why I want to think about this is that there's all kinds of things that you can show to management in the dashboard. You can say, hey, how's my demand versus sales, right? How is my manufacturing capacity versus sales? Am I really making a good profit given the demand and sales and the cost? How so if my manufacturing capacity is this way, can I meet the monthly demand? So there's all kinds of things you can do with these, and that is why I just created this design. Okay. Now the other thing that I did is that just to have fun, I kind of created these tables like these product demand, product cost, and product manufacturing capacity tables in MS SQL. Okay, and the product sales I want to keep it in Excel or keep it as a CSV. Okay, and we're going to look at how that's going to work. Just I want to show you how you can pull that in the Power BI tool. Okay, so I did that. Okay, now let me get to Microsoft SQL or MS SQL. Now, by the way, this machine is a Windows 10 machine, and it looks like Microsoft is finally providing you free copy of MS SQL, which you can download. And not just that, they're also providing you a nice SQL Server Management Studio tool, also free. Just go to the Microsoft website, search for it, and download it. So I downloaded both because it's free. Okay, and it works pretty okay. There was little bit quirks here and there because it's very long since I've used MS SQL. Man, I think I used it 15 years back in one of my previous companies, because the world has changed so much. But the database concept, the relational database concept is very similar. And I will tell you this, that if you're into the business modeling, business analysis, data modeling, process modeling, you're better off learning some of the database concepts, right? Which I have told you already. And I think you're also better off learning SQL, which is the structured query language. Very simple language, just learn it. You don't have to be an expert in it, but figure out how to query, how to join, things like that. There's thousands of tutorials online. And I would also recommend that you pick up one scripting language that you like. Okay. It doesn't have to be, you don't have to be an expert in that language. Just pick up one language. I would recommend Python because it seems to be simple to me, right? Now, I've also explored some of the modern languages from a scripting point of view. I think Python is good. I also nowadays I like Go because in the AWS world I like to code in Go, so I sometimes write stuff in Go. But Go is a nice language, right? But it's a full-fledged language. It's not a scripting language. Okay, so therefore Python is good. Perl is good, but seems like Python seems to be more fashionable. So try it. Okay, learn and pick it up. Now, for our purposes, obviously I used MS SQL, and to create the data I used Python, and I'm going to show you that. Right, today it's just going to be how I prepared the data, what is the data model, and can I import that data in Power BI is what I'm going to show. In the next class, I'll actually show you some of the what is that called as the DAX magic that you can do, the data analysis expression. There's a language where you can add a column, you can add a table, you can make summary data, you can make functions from that expression language, right? We learned that because that's the power of Power BI. It sounds to me like that. Okay. Anyway, So right here I created the database, and I created a database called ProdWorks, just to have a cool name, or ProductWorks. I called it as ProductWorks. Then I created those manufacturing capacity, product cost, and product demand as tables. Exactly based on that model I showed you, I created the table design, right? So I can show you the design. I don't know if I can do it at the database level. Is there a design? No, there's no picture that I can show you. But, pretty much it's the exact same design model I showed you before, okay? Okay, so the next question comes like, okay, you created the tables, you already decided one is going to be CSV. So how do I get the data? Now, even in large companies, you can, if there is a production database this way, you will never be provided the production database to play around with, right? If you're a ETL or business intelligence data analysis developer, they're just going to say, hey, use a test database, okay, or a dev database. And then when you go and ask for data, in some cases they may give you data. I mean, you can just put a request to the DBAs and say that, hey, copy all my production data and pull it down to test if the data is not sensitive. Now, there are some companies where they have some scrubbing and tools where they can scrub off some sensitive data and then give it to you. In many companies, they will say that, no, I'm not going to give you any data. Make your own data up. So, where will you make up your own data? Okay, that's one question. The other question is, if you know how to make up data, the skills that you need to make up data, using something like Python. And by the way, Python has a very powerful mathematical library and statistics library that you can use. Okay, so if you use Python, it's very easy to actually create realistic data based on certain understanding of the business. Now, where that skill is going to be very useful is that when you make that kind of test data and build your BI, dashboard and everything based on that test data, it becomes a very good way to test your model as well as your dashboard against some assumptions that you can say that, okay, once I played around with it, and once the data looks like this and I can visualize the data, then I'll go and actually deploy it in production where I have the ability to see the real production data, right? So having the skill of preparing and creating and producing and making up data is very useful for you, okay? So I'm just going to show you one way of how to do it. You don't have to follow the same way, but it just provides you an idea, okay? Now, this tool I'm using is PyCharm, and basically it's a very, very nice tool for, and this is Python script, okay? Now, since I am a software engineer, I just have the whole range of idea products. I just subscribe for it, right? And it comes with PyCharm, Golang, and things like that, and it's very reasonable for a developer. Okay, you can do that. I think there's a free version of PyCharm. I don't know, but I've also coded using Visual Studio Code. It's pretty good, and it's free. But you probably need to download some plugins for Python. You can do that too. And the nice thing with this is it's actually integrated with source code control. Visual Studio Code is also integrated with source code control. Okay, so you can use that all the time. And then what I will do is in the bottom of this video, I will put my, so I have all this code uploaded in GitHub. So I'll put the link to GitHub of this code. It's public because there's nothing rocket science here. Okay. So you can actually clone it from GitHub. and you can make modifications to it. You're free to do it. There's no licensing, nothing here. The only warning I'll give you is that when I wrote this code, and I actually called it as ETL, right? ETL stands for extract, transform, and load. So in a typical enterprise, you have a lot of ETL systems that loads data or prepares data or creates data, okay? And the warning I have is that, so it is writing data to MS SQL, right? But I didn't use any MS SQL specific dialect. It's a generic SQL dialect. So it can in theory run on any database, okay? And I'm using the Python's ODBC driver, and that to an older ODBC driver, which is PyPy PY ODBC library. Okay, so you see it's here, PyPy ODBC. Okay, so ODBC, as you know, is a generic driver which can connect to any database. It can connect to Oracle DB, to MS SQL, Postgres SQL, whatever. Okay, so it can use that. The only caveat here is that what I have not done is I've not done the traditional SQL error handling, which is you'll have a try block, catch block, you'll have a commit and rollback, things like that. Okay. The reason why I didn't do that is that the script is very simple. There is like 5 or 6 queries, and if it errors out, and that's it. Okay. What I've done is to make this process really repeatable. I have provided a cleanup function, which means that it will go and delete all the data. If you have messed up something and you're running it, you can rerun it after correcting it. It's just going to go and delete all the data. It's not going to drop the tables, but it's going to delete the data. So you can always run this script as a repeatable process, right? So that's the only warning I'll give, that if you want to run this kind of thing or copy this kind of thing for a production system, you probably need to take a look and probably provide some error handling, okay? But otherwise, the script can be reused, okay? Now, I wantedly made it, obviously I'm a software engineer, so if I don't make it, it's shame on me, right? I wantedly made this really modular. What do I mean by that? What I mean by that is that you see that there are 3 config files, Python files. One is called as ETL config, and I'll show you what that is. Another is called as a product config, and another is called as a product query. So what I've done is all the constants, configuration things are all externalized from this program, so that you can customize your rules, the data preparation rules in one place. Okay, so without touching any of this logic, you can go and customize those rules and you'll get different sets of data. Okay, and I'll tell you how I did that magic. It's very simple, it's not rocket science, but I need to explain to you how I did it. Okay, so first let me jump to the ETL config just for you to understand what I did. So the first thing that you need to provide for ETL is a connection string. Okay, now this is a ODBC connection string, and so it's going to differ from database to database. Okay, the one that I provided is obviously an MS SQL string. Okay, MS SQL is quite simple, because all you got to say is that the driver is for SQL Server. It's the local host because you just downloaded it in your personal laptop. What's the product name? And then you need to say it's a trusted connection. Okay. What does trusted connection mean? The database is in my machine, and if I logged into Windows, then that's the login you need to use to log into the database, right? So you don't have to provide user ID and password, and people like me, I can happily show you this so that you can't hack my system, because I'm not providing any details about user ID and password. Okay, that's one. The second thing is, as I told you, that I'm creating a CSV file for just one, the sales part of it. So I'm just mentioning, hey, what is the directory of it? I'm just saying that, hey, it's from wherever my Python script is running. From there, there's a directory called data. Inside that, just create a file called sales.csv. Now my CSV file needs some header. So I'm just putting the header, same table structure. I'm just putting that as the header here. Okay, so that's your ETL config. Now, therefore, you can easily modify this and change your database, change your CSV location, all of these things easily without touching the actual logic. Okay, that's why that part is externalized. Now, let me go down to the product config, and this one I got to explain to you a little bit. And I'll go line by line and explain it to you. The first one is an array of products that you're going to build, or you're going to make up, right? You're going to create. And I kind of model like, my company is selling hard disk drives or solid state drives, and then I put some models. Okay, it's 1 terabyte, 2 terabyte, 4 terabyte, 8 terabyte kind of thing. You can make up whatever the product is. The only advice I'll give you is that for your graphs, your product names, if they are smaller, they look nice, right? But of course, in real production, you don't have that luxury. But here, I just made the product names a little smaller. Then the available lots, this is interesting. This is just an array of different lots or quantities that I can say that, okay, if I'm manufacturing this much quantity, this will be my price range, right? So it's just a manufacturing threshold of quantities that I can connect, I can relate with my cost, okay? So I've just provided 5 ranges: 50,000, 100,000, 200,000, 400,000, and 800,000, okay? Now the costs, we need to make up costs, okay? So again, in order to make up costs, I'm going to use the Python's random function, and Python as a random library that I can use. There is also a library called NumPy, NUMPY, okay? Now that is a lot more sophisticated library, because here I can generate random numbers within a range using uniform distribution, right? But NumPy can generate arrays of random numbers using all kinds of distribution, binomial, exponential, literally 30 or 40 different types of distributions. It can generate random sample data. So if you're deep into creating that kind of data, I would recommend you to go and master NumPy, okay? It's a very good statistical mathematical library. But for our purposes, I'm just using random uniform distribution, and therefore my unit cost, I just made up some range, okay, unit fixed cost, okay? And that's because for 50,000 items, I'm saying that, hey, my fixed cost is $2.25. So you multiply 50,000 by $2.25, you get the fixed cost, okay? And the variable cost, since these are hard disks, I just made it up. I said that, hey, my hard disks are going to cost me $50 to $80. Now, obviously, each product may be costing differently. I could have made ranges for each of these products. See, that's where NumPy is very powerful for that. But right now, I just said that, hey, I'm just going to assume that all my hard disks are going to cost more or less the same, but it's randomly picked up. So I'm just saying that it's going to cost, the cost range is going to be starting at $50, ending at $80, okay? Now for outsourcing, I used a percentage calculation. So that's why I have a outsourcing cost factor, a start and end range. What I'm saying is that if your product manufacturing cost, both fixed and variable, added together, it's going to cost you $4. Then if you outsource it, the cost is going to be more in this model, okay? It's going to be more like it's going to start with, it's going to be more about 1%, right? Two, it's going to cost 5% more. So it's 1% to 5%. And you randomly pick up something, okay, to make up data. So that's the outsourcing factor. Then manufacturing is always this an element of uncertainty. So I want to be realistic and say that, hey, I have a manufacturing capacity, but there is also an uncertainty of it, okay? And I'm saying that, hey, it can vary from minus 5% to plus 5%. In other words, that, I might not make 100% of my capacity. Sometimes I can make more than my capacity. How can that be possible? Because you bought a new machine, there are no excess employees available, the raw materials you got it cheaper, so you got it more, things like that, okay? Sometimes you can manufacture more, sometimes you can manufacture less. So I'm saying it's plus or minus 5%, okay? Then the sales factor, I'm saying it's going to be plus or minus 10%. That means if you have calculated your demand as something, this is my demand for this region. But really speaking, your sales may be, it can be 10% more than that calculated demand or 10% less than that calculated demand. Okay, again, I can use random numbers to go, I can use the Python random generator to go and say, hey, within that range, pick a number and give it to me, okay? All this is to make the data more realistic, okay? That is my available region. I just made it up here as US states, and I'm only picking up 5 states just to make the data not that complicated. You can do whatever you want. See, any of these things, you can increase the number of items in the array as well as you can change your ranges. But if the available region is like that, then you got to say that, hey, this is my regional bias. So that means that of the total demand that I have, 30% of my demand comes from California, 25% of the demand comes for Texas. So basically your available regions, how many ever you put in this array, that many items you need to put in this demand bias, and you're going to talk about, if this is all percentages, so you're saying 30% comes from California, 25 from Texas, 20 from New York, kind of like that, okay? And then price markups. So throughout, I'm going to calculate the data on what's my demand, what's my sale price, if what's my sales, right? If my price is marked up 5% from the product manufacturing cost, 10%, 15%, 20%, right? Okay. Then just for adding some kind of seasonality into my data, there's also a slope increment. That means that every month my sales and my demand is going to increase by certain percentage. Okay, I just put 2.5% here. Okay, so this is the configuration, this is the setup, this is how your model is going to work. So once you clone the code, you can change these numbers to generate different kind of test data, okay? That's why I put that in here. So then let's go into another configuration, sort of configuration item. You don't have to touch that much, but I just want to show you it is externalized, which is the queries themselves. So these are all the SQL queries that I'm using. This is all the queries that I'm using in my script. And if you see that there is a bunch of delete queries, this is for cleanup. There is an insert query to insert a product, right? And by the way, I'm taking advantage of the Python formatted named strings, which is very, very cool, because if I have this is like a template, right? and the actual product name can be assigned later. So I'm just creating a string with some names within the curly braces. Those names can be replaced by actual data later. Okay, so I'm taking advantage of that. And you can also see I'm using the triple quote. In Python you can do triple quote and then have your string span multiple rows. So I'm taking advantage of that too. And so there is an insert query to insert data into product. There's one to insert into product cost table, another to insert into product manufacturing capacity table, and then there's one more to insert into the demand table. Okay, and finally you have a select statement to get the products. Okay, so I've explained all the configuration items here. So chances are you don't have to touch the product underscore ETL py file at all, right? You don't have to touch it, but I just want to actually walk through what I have in the ETL Python script so that you can understand what is going on. Okay, now obviously I'm not teaching you Python here because there's enough tutorials online to go teach you that. I'm not going to teach you that. In fact, I learned everything online. I didn't even go to any class. Okay, but just go through the code. I'm just going to show you line by line what the code is doing. So you can reuse this code. You can pick up some Python skills later, but this code can be used. And then for those who already know Python, I'm just giving you an idea of how to prepare data for your data analysis. Okay, let's go to Python. Now obviously here are some of the things I'm importing. The PyPy ODBC, as I said that I'm using ODBC to connect to MS SQL database, so I need that. I am definitely getting the random library, so I use that. So these are the only two libraries I pulled, right? And of that, this PyPy ODBC, you need to do a pip install. So you got to pull that dependency into your system. And usually in Python you use a pip install, pip install, right? That basically pulls the library for you. Then I have my own three internal config classes: the product config, the product query, and the ETL config, which I explained right now. So this is one of the, I would say it's Python idiom, where you take all the constants and define it in another file and then pull it down so that you don't hard code any of the stuff. Okay. So that said, that I've written a lot of little Python functions. That's how you do it in Python. You write a lot of functions. The one function you write is the main function. Okay, again, there's no need for building or defining a main function. Python doesn't work like C, where you got to have a main function. Any code you write without a function, without the def name in it, is going to be executed. But it's the best practice to actually write a main function and then have this if block. Basically, this if block says that, hey, if you're running in the main context, then run this function. Okay, because Python has this weird thing that when you're importing some file, the part of the file that is not under any function will get executed, right? And that is why if you write this line saying that, hey, if you're importing, I don't want to run you this main function. I don't want you to run anything, right? Just import the file. That's why we just put if name is main, then run the main function. Okay. Anyway, let's look at the main function. Of course, the first line is very obvious. You're trying to get a connection for MySQL. Okay, it's very easy. As long as you have the connection string, you just are saying connect. That's it. The other concept in Python is the concept of a cursor. Obviously, if you're in the terminal, you have a cursor. That's where you type the command. Same way, when you get a connection, from the connection you say that, hey, get me a cursor where I can execute SQL commands. That's what that cursor is for. Okay. So for everything that you want to do with the database, you need a connection and a cursor. Okay. Then you're calling the very first function, which is the cleanup function. So cleanup. And what I do here in the cleanup function is that I am deleting the product cost query, demand query, capacity query, and product query. Now I'm doing it in certain order so that all the foreign key dependencies or dependency tables, the data for that is deleted first, and then after that I delete the product table. And then of course we should never forget that every time you're doing anything in SQL, you got to commit. Okay, that's what I'm doing there. Now the one thing that I did is that for the file, I made it very simple that I open a sequential file in write mode. Okay, so when I'm opening a sequential file in write mode, the previous data gets overwritten. So I don't have to clean up the file. The file is already there, it has some data, but every time I just run the script, I create a new file. Okay, so therefore there's nothing in the cleanup code for that. Okay, if you're curious about that. Okay, so I'm doing a cleanup and then I'm creating the products. Okay, creating the products is also very simple because I already defined the products in an array, right? So all I'm going is that I'm just saying that, hey, from the product config, whatever the products are, go each product name by product name, and then insert that using the insert query. Of course, this is where I told you that you can do a format and you can say that, hey, by the way, whatever that thing is in the curly braces, let's replace that with the actual dynamic variable, right, which is the product name. And you're doing that through a loop. And at the end of the loop, you're doing a commit. Now, you may ask, hey, where is the product ID? Well, in MS SQL, if you go to MS SQL, there is a way. Let me get the product design. So there is a way to automatically generate the product ID. Okay, the way you do that is you go down to the table designer and there's a thing called identity specification. The moment you put identity specification is yes, then you can tell that what is the starting number you want to put and how much you want to increment. And what my MS SQL will do is when you don't specify that field and actually insert, when you run an insert statement, it will automatically pick up the number from here and then the next number will be whatever is in the sequence. So it will automatically generate unique sequence IDs, and that's what I'm using here, okay, just for you to understand. So I create the products, then going back to my main function, of course I'm defining the slope factor as a temporary variable, that's fine. I'm also making sure that I'm opening, remember that I'm opening the sales file, the CSV file. I'm opening it in write mode. Now in Python, if you're doing sequential files, you can open it in write mode, you can open it in append mode, and you can also open it in read mode. Obviously, if it is read mode, you can only read the file. But if it is in append mode or write mode, you can write to the file. In the append mode, you're always writing to the end of the file. So that means it preserves the previous data. In the write mode, it goes and writes in the beginning of the file. Therefore, the previous content of the file gets erased. Okay, good. So, and then I'm also writing the header of that file here. Then I'm coming and executing the product query. The reason why I need to execute the product query is, see, when I insert the products, that's when I know what is the product ID. So now I need to get the product ID and do some stuff. Okay, so that's why I'm querying it, and with the cursor I'm executing a command saying, hey, fetch everything. Okay, then I'm going row by row of each product. Basically for each product I'm finding the product ID, and the first thing I'm doing is I'm creating the product cost data record. Okay, what do I do to create product cost? Let's look at it. Create product cost. Okay, you're giving it a parameter which is the connection, the cursor, and the product ID. So for one product, you're making up the product cost. How do you do it? So remember that I had this lots where I said that, hey, this is the lot in which I can manufacture, because in our model at least, that the more products you manufacture, the more the costs are going to be. Okay. So I'm going lot by lot. For each lot, I'm calculating the fixed cost, the variable cost, and the outsourcing cost. Then I build a insert query, insert, execute that insertion, and then end of the loop. Remember that this is a loop. End of the loop, I commit. Okay. Let's look at these calculations. The fixed cost, I calculate it very simply. Basically, I'm just using random uniform function of the fixed cost range starting and ending. So it will pick up one number. Okay, and again, that random uniform function is actually going to pick up some number. And I'm kind of saying that, okay, that's the unit fixed cost. So to get the total fixed cost, I take the lot number and multiply that with that random number that is selected, and I round it to two places. Okay, that's what these lines are about. So for the variable cost is very simple. I just generate a random number between a start range and end range. Remember, it was 50 to 80, and then rounding it. Okay, nothing big about it. Now, outsourcing cost, I need to explain it a little bit. So for the outsourcing cost, what I'm doing is that, okay, I already know the fixed cost, the total fixed cost. So I take the total fixed cost, divide that with the lot number. That means that I get the unit fixed cost. So that is the unit fixed cost plus the variable cost. That is if you're manufacturing in-house, that's the cost price of manufacturing one unit product in-house. Okay. Now, obviously, I told you that in our model, and you can change that model, but in this model, I said that, well, if you're outsourcing, it's going to cost you 1% to 5% more than manufacturing in-house. And so that's what I'm doing here. So I'm taking the unit cost, then I am multiplying that with, or I'm saying that, okay, take the current unit cost plus figure out my outsourcing factor, a random number, and then add, so that random thing is a percentage. Okay, and take that percentage, and so with the current cost, add some percentage of cost. That will be your outsourcing cost. That's what I'm doing here. Again, rounded to two places. Then after that, I'm creating an insert query. Obviously, the query itself is in the product query Python file, but I need to provide all the variables. I provide product ID, lot, fixed cost, variable cost, and outsourcing cost. That gets inserted into the product cost table. And of course, I execute it, and after all these, I've inserted records for every lot. I commit the connection. Okay, going back here. So let me go down. So for each product, I created the product cost. Now then what I do is that now I need to get into the demand and capacity and sales kind of thing, right? So what I'm doing is that, to start with, I calculate the base demand. Okay, the way I calculate the base demand is I'm just saying that, hey, my base demand will be just a number between the lowest available slot or lot, which is 50,000, and the highest available lot, which is 800,000. So it's a number between 50,000 and 800,000. So that's kind of my base demand. Okay. Basically, I'm saying that it's a random number that is within my manufacturing capacity. Okay. That's what I'm saying with that. Okay. Now, now the demand is going to fluctuate a little bit, but I could have even said that hey, it's a little bit more. The maximum number is a little more. It's not 800. If I want to show some good data on outsourcing, then I'll probably say that hey, it's 20% more than that. But right now, it's just I'm picking up a random number between the minimum lot available to the maximum lot available. Okay, so it's between 50,000 and 800K. That's the base demand. Then I loop over for each month, okay, 1 to 12. I now calculate the manufacturing capacity, and then I also calculate the demand and sales, which is in one function, okay, and I'll tell you why it's one function. Anyway, let's look at how I create the data for manufacturing capacity, okay. For manufacturing capacity, I have this function. Basically, I kind of find out what is my manufacturing uncertainty. Again, I said that it will be between -5% to +5%. But I choose a random one between that range. Okay. And I say that that's my manufacturing uncertainty. So once I know the manufacturing uncertainty, then this is what I do to calculate the manufacturing capacity. What do? I take the available lots. Okay. I'm taking the maximum of the available lot, which is 800,000. Okay. So I take the maximum of the available lot. Then I multiply that with, or I do it in such a way that I take that, whatever that highest thing is, then add or subtract the manufacturing uncertainty percentage. Okay, so a percentage of that cannot be done because of manufacturing uncertainty, and that's what I'm subtracting or adding. If my uncertainty tells that hey, it's a little bit more, right? And I come up with a manufacturing capacity. Again, to just be the point of all this is to have some kind of realistic data. Okay, that's all it is. So then I'm giving the product ID for a month. What is my manufacturing capacity? Executing the SQL, right? And then committing it, right? It's as simple as that. There's no loops involved here. Okay. Now, obviously, the next function is about demand and sales. The reason for that is you can create demand in the table and sales in the file, but the calculation are very, very related. So that's why I wrote this function called create demand and sales. Okay. So to this function, you provide the connection cursor product ID for a month. Okay. What's the base demand? Because that we calculate in the beginning itself. Then what's the slope factor, which is, as you know, that your data gets little bit of a push every month, increments every month. So what is that? And then what is the file where you want to insert the sales data? All of that is passed as a parameter. Now I'm calculating the sales factor. I'm saying that a sales factor is, it'll be -5% plus 5% is what I think I made it, right? So I'm just choosing a random number between that range. Okay. Then I do have an array of markup. So I'm going with each markup. I'm saying for each markup, your base demand will be discounted because your markup tells you that your demand is this much, right, for a product. But as you do if you say that, hey, I'm marking up this much more, so if your price is increasing, the demand is decreasing. That's what this formula is about. Okay, take the demand and subtract whatever you're marking up, the markup percentage. Okay, then multiply that again with the slope factor. That means, there's a small percentage of more quantity will be demanded because it's the month of March. Okay, so I'm making an assumption that in the month of March you're selling, your demand is more for the product than month of February. Okay, so I do that, right? So that gives me the current demand for a product. Okay, then I'm saying, okay, so the actual sales, I kind of derive sales from the demand. I'm saying that, hey, my demand plus whatever the sales factor is. Okay, so demand into 1 is demand plus demand into sales factor is a percentage of the demand. So I'm just saying that, and that's a positive or a negative. I said minus 5% to 5%, right? So whether it's positive or negative, it will add that or subtract that to the actual demand and say that, hey, that's the actual sale. Okay. Now, but that data is not enough. You got to know what is that for the region, right? So that's why you loop over the region. And I say that regional demand is actually the demand multiplied by whatever the percentage regional bias is for that region. Okay. The way I do it is I take the regional bias array and I provide an index for it. How do I find the index for it? Is by looking at the available regions array, right? And say that, okay, for the region of Texas, what is the index? You take that index and say that, hey, what's my regional bias? Okay, so that means it's Texas, and so it's 25%. That is what this line of code will provide. Now, you're building the demand SQL, right? And for the demand, you need the product ID, the month, the demand, okay, regional demand. So I create that row, execute it, commit it. Now, sales on the other hand, you'll have to say that, okay, I have sales, right? The regional sales. So here the sales is calculated as, okay, what is the actual sale for that specific markup? Then multiply that with whatever the regional bias is. Again, regional bias, take the available region and find the index of that region, and you get the regional data, regional sales data. Okay. And finally, the sales data is going to be inserted as a CSV row, and I'm using the Python formatted string. You just put a F in there, and when you do that, whatever is in the curly braces is actually a variable. So in this case, given product ID, comma, region, given month, markup, and regional sale. Okay. And so if you look at the main function, that's pretty much it, right? And of course, in the month, as I progress through the month, the slope factor is increasing. Okay. It's always increasing by a increment, slope increment. Okay. So your m value, that is the slope itself, is increasing over time, and I'm putting that here. Okay. So that's the slope increment. Okay. Then of course I close the file, I close the connection, which is very important because you've got to close those things. Okay. So that's pretty much what the script is about. Okay. And then I can run the script. All I need to do is press that button and it silently populates all the data. The data really populated? Sure. Go look at it. So this is the sales CSV that got populated with the data. And if I go to MS SQL and I look at the manufacturing capacity, and there's a way to look at it, edit top 200 rows, you will see that, okay, here's my manufacturing capacity. And here's my products, right? Here are my products. Here is my product cost. Costs are all there, okay? Here hard disk sometimes costs you $68, sometimes $71. But if you're outsourcing, it's going to cost you $79. You see that? So the cost is all calculated for different quantities. Then you have the product demand, and let's see. So that gets you the demand. I just took a sip of tea. Then that's the product demand, and that's pretty much it here, right? Because sales is not put in here. So what I've demonstrated is using Python script, using a little bit of your common sense and some random variables, you can actually generate some realistic data. That's what I've proven here, okay? And also Python gives you flexibility of changing your data sources, right? Now, for the next class, I've actually downloaded the Postgres SQL database, and I also downloaded a NoSQL database, just to show you that Power BI, you can use those data sources too. Now let's go to Power BI and see how to configure these data sources, right? Let me see if I have the Power BI open already. No, I did not. Okay, let me open Power BI. Where is Power BI? And after that, I think the actual building of the Power BI dashboard we'll do it next time. Okay, so for now we have Power BI desktop. So open that. So by the way, this code, as I said, that I'm going to put it in GitHub, so you can download it, you can clone it. Okay, so let's say that I'm going to create a new report. Okay, and I go and say get data. First data, I need to get it from where? From, what does it say? Data rows, data words, SQL Server. Okay, so let me click on SQL Server. It's going to ask for the server and the database. I'm just going to say localhost. Local gist. Local. I'm trying to get familiar with this keyboard. Let me see if I can take this laptop. Well, I can't. Okay. Okay, and database is optional, so don't worry about it. And you say import and say okay. It's going to pull the whole database, and then it's going to say, hey, which one you are interested in. Obviously, I'm interested in ProdWorks, and I'm interested in all the database, all the tables, right? Okay, so I select that, I select that, I select that, and I select that, and I say load. It's going to load them. can say, well, it's still loading. So let it load. Okay, it loaded everything and I applied the changes. Okay, I got that data. Okay, and then again I'm going to say get data. This time remember that I need to pull a CSV file. So I say text or CSV file. Obviously it's going to ask for the location. Location is under C. I got to go look at the users and my name. And under that there should be PyCharm projects. This is just a directory where I have my project. Okay. Python ETL, data, and I have the CSV file. I say open. Okay, so I got my data, and remember that since I inserted the header, it's also showing me the header. Delimiter is comma, and your data type, it kind of detected it based on the first 200 rows, whatever. Say load, and I think it loaded. So how do I see all my data sources? You click on, well, I should have shown, you click on that icon. Okay. So nice thing about this is it is already, since the foreign key relationships are already there, it already created your database or tables with that foreign key relationship diagram. That's so cool, right? So it already did that. And it even tells you, hey, is it one to many? Is it one to many? Right? This is the product table. So it says, hey, it's one to many, one to many, and one to many. That's nice. But of course, you have the sales table. And the sales table, I'll tell you the one complication is I would like to actually link it with the product demand table because both of them have the same primary keys, right? So I have the product ID, the month, the region code as my and the markup percent as my primary key, right? But I'm going to tell you one thing that Power BI has a limitation that it doesn't support composite keys. Okay, and there's a lot of debate in the internet on, hey, that's very simple. Why is Power BI not supporting composite keys? It's just, it so happens that it's not supporting composite keys. Okay, so the only way you can have a composite key is you can have a calculated column and have the composite key and then do a relationship, or you just make it up in when you're building your graphs and reports. Okay, my case, I'll show you both the samples, but right now I'm just going to show you how I do a simple relationship. Later we'll do the calculated one. Okay, so in that way I'm just going to make sales also relate with product table. Okay, how do I do it? It's very simple. You see this dot, you click on that, you click on manage relationships. It already shows some relationship. It says that a manufacturing capacity is related to a product by product ID, right? So you click on new, and now you say that my table A is going to be product, and my table B is going to be sales. Remember, that's the CSV. And then you select the product ID as the column for products and product ID as the column for sales. And obviously it's a one-to-many relationship. It automatically detects that. Cross filters direction is single and say OK. So it added that relationship, and then once you close it, it also created the relationship with the sales table now. Okay. That is it, guys and girls, that this is all you will have to do, right? So now you got your data, you prepared your data, you wrote script for this data, you even differentiated the data sources, and you put the data together. So now that I have all this data, it's quite easy. I'm not going to build an actual dashboard right now, but I'm just going to demonstrate something simple, right? Okay, I'm just going to try some sort of chart. What chart I can, maybe is that an area chart? Okay, let me do an area chart just to give you an idea of how you can once you have the data, what you can do, right? So you go to the focus mode. I usually go to the focus mode, and let's say that I'm studying sales. Okay, so I can put the month in the x-axis, you know, and obviously the total quantity in the y-axis, and that's the sum. There is the thing, right? As the month increases, my quantity increased. Okay, my sales quantity increased. And obviously you want to divide it by the region, right? You probably need to include products too, but right now I'm just going to take the region and put it in the legend. Oh, there you go. So each region, what is the sales? It shows, it kind of divides and shows you in the area chart. Okay, so each region is making sales, and it's approximately, and I can see that California has that much, and see the legend is also great. So you have data that you created it. Now there's a lot of things that you can do because you have so many tables and so much of data, and you can combine them. That's where we have opportunity to use like DAX functions and stuff like that. Now that we will talk about it in the next class. Okay, but right now I'm just going to summarize what I've taught you. I'm just giving you an idea that you can download your SQL, MS SQL, download it for free, build some tables, go and build some Python script. You already have the Python script in GitHub. You can clone it, modify it, make some changes. Main thing that I showed in the Python thing is that I'm using random uniform to generate some random data, and I've externalized the SQLs by inserting, externalize some of the configuration that I don't want to hard code in the main script file, and then I externalize the ETL configuration, which is like connections and stuff. And then I also explained to you the whole Python scripts. Okay. Then I also showed you how you can import the data into Power BI and how you can create relationship between a non-SQL table and a CSV data, right? Only limitation I told you is that Power BI does not support composite keys. Okay. And once you have the data, you can build your dashboard just by dragging and dropping. Now, of course, the more advanced version of how to build the dashboard and how to actually provide our CEOs and the executives with some kind of decision making ability, we'll look at it next class. Of course, this itself is a big class, so thank you for your patience. Go through it, take breaks, have coffee, whatever, and then we'll see you in the next class. Thank you very much.